In the last class, we have discussed about spherical surfaces and the types of lenses, uses of lenses, and also we have discussed how a lens forms image. And we also discussed an equation for the refraction through a spherical surface. Now in this class, we are going to discuss about the behavior of light ray when it is dispersed on a lens. This is one of the important basic concepts that we need to understand in this chapter. If we understand this chapter completely, we can easily draw the ray diagrams of a concave lens or a convex lens. That's why this topic is very important while drawing ray diagrams. Let us try to understand the behavior of light ray when it is passing through a convex lens or a concave lens. Here are few cases that we need to understand. The first case, before going to take the first case, let us try to understand how we denote a convex lens or a concave lens while drawing ray diagrams. If you observe carefully, this symbol indicates a convex lens, that means biconvex lens, and this symbol indicates biconcave lens. So while drawing ray diagrams, we use these symbols only instead of convex or concave. Let us try to understand the cases one by one. The first case, a light ray passing along the principal axis. What happens when a light ray is passing along the principal axis? So when a light ray is passing along the principal axis, it is undeviated. That means there is no deviation in the light ray. That means it will pass along the principal axis. So here are the ray diagrams for this. You can observe here. So this diagram shows a light ray passing through a biconvex lens. You can observe here, it is undeviated, that means no deviation in the direction of the light ray. And this diagram shows the ray diagram when light ray is passing along the principal axis through the concave lens. It is also undeviated. So first important point we need to remember is when a light ray is passing through the principal axis, it is undeviated after refraction. And now we go to the second case. When a light ray is passing through optic center is nothing but pole of a lens. So how it behaves after refraction? When a light ray is passing through a convex lens or a concave lens, when it is passing through the optic center, after refraction, here also it is undeviated. That means after refraction, when a light ray is passing through the optic center, it passes in a straight line, undeviatedly. Observe the diagrams here. So here I have given a diagram showing a light ray passing through the optic center through the biconvex lens. When it is passing through the optic center, it is undeviated. It travels in a straight line, no deviation. So in these two cases, that means when light ray is passing through the optic center or when light ray is passing along the principal axis, after refraction, there will be no deviation. It is undeviatedly travels. Now let us go to the third case. When a light ray is passing parallel to the principal axis, what happens when a beam of light rays passing parallel to the principal axis? Either it may be a biconvex lens or it may be a biconcave lens. So here I have given ray diagrams for both of them. The first one. The first diagram shows a beam of parallel light rays passing parallel to the principal axis and traveling through the biconvex lens. So what happens? The parallel light rays which are passing parallel to the principal axis, after refraction, all the light rays will converge at a point. Converging means meeting at one point. That means they are intersecting at one point. So a convex lens always converges light rays at a point. That point is called as focus or focal point. So when a beam of parallel light rays passing parallel to the principal axis, all the light rays will converge at focus after refraction. Now let us try to understand what happens when a beam of parallel light is passing through the biconcave lens. So here is the diagram which shows parallel light rays passing through a biconcave lens. So here in this case also, when a beam of parallel light rays passing parallel to the principal axis, after refraction, all these light rays will diverge. You can observe the light rays are diverging. That means moving away. So a biconcave lens always diverges the light rays. That's why the all light rays will meet at the focus. That means when the object, in the case of biconcave lens, the object and the image will form at the same side of the lens. So here is the lens and the object image both will form at the same side of the lens. But in the case of convex lens, object is one side from the lens and image will form to the other side of the lens. So this is the difference that we need to understand here. So in these two cases, when a beam of parallel light rays passing through the lens, that means passing parallel to the principal axis, if it is a convex lens, they will converge at focus. If it is a concave lens, here also the light rays diverge, but all the light rays will meet at focus. Next, fourth case. So here is the another case that we need to understand. When a light ray passing through the focus, that means when a light ray is passing through the focus, what happens? Let us try to understand. So here is the diagram showing the light rays passing through the focus on a biconvex lens. So here is the focus. The object also at this focus. The light rays from the object are passing through this, and after refraction, all light rays are parallel to the principal axis. That means when the light rays are passing from the focus, that means passing through the focus, after refraction, the light rays will be parallel to the principal axis. Same, it is applicable in the case of a biconcave lens also. And now the last case and the fifth case is when a beam of parallel light rays falling on a lens making some angle. So you can observe this diagram here. So here a beam of parallel light rays falling on a biconvex lens making some angle with the principal axis. What happens in this type of case? So here we know that a convex lens is a converging lens. So when a beam of parallel light is falling on a convex lens, all light rays will converge at a point, and that point will be on the focal plane of that lens. That means focal plane means here is the focus. If we imagine a plane on that focus, that plane is called as focal plane. That means when a beam of parallel light rays passing through the a convex lens or a concave lens, all the refracted rays will meet at a point on a focal plane. Now, let us have a brief revision of all these five cases. The first one, when a light ray is passing through the principal axis, it is undeviated. In the second case, when the light ray is passing through the optic center, it is also undeviated after refraction. Third case, when the light rays are passing parallel to the principal axis, they will converge at focus for a convex lens, and for a concave lens also they will meet at focus and they will appear to be convergent focus for a concave lens. And the fourth case, when a light ray is passing through the focus, when a light ray is passing through the focus after refraction, it will be parallel to the principal axis. And the last case, when a beam of parallel light rays falling on a lens, all the light rays will converge at a point on a focal plane. Either it may be a convex lens or a concave lens. So these five situations are important to remember in this class. So after that, in the next class, we are going to discuss about the ray diagrams of a convex lens.